And the third part of power system is the power distribution. After the power is transmitted to the distribution substation, and the power will be distributed to the load, scattered around the substation. And it is the green lines here. And the distribution distance is about 10 kilometers or even shorter. And there is usually a trade-off of the cost and the reliability of the distribution system. Here is an example. This is the bus of the distribution substation, and these are two feeders, and there are 4 loads here, load A, B, C, D, and the blue one are circuit breakers. So in normal case, the power can be distributed from the bus to load A and load B by feeder 1, and divided to load C and load D by feeder 2, just like this. And if a ground fault occurs here, what is a ground fault? Ground fault means the power line is connected to the ground, and the resistance between the power lines and the ground is almost zero, so the current will increase. So it will harm the feeder or the power line. So in this case, we have to cut the current here by open the circuit breakers, just like this. The circuit breaker is open, so the current cannot flow to load A and load B. But in this case, only load C and load D can have power to use. But if we open this circuit breaker, both load A and load B have no current, and this is very bad for load B, because the ground fault occurs here and has nothing to do with load B. So can we, if we want to increase the reliability, we may want to supply power to load B when the ground fault occurs here. How can we do so? Yes, we can. In this case, if we add 3 switches in here, here, and here, then we can increase the reliability. And the 2 switches here are closed in normal case, and the switch here is open in normal case. Let's see what will happen. In normal case, the bus of the distribution station can supply power to load A and load B by feeder 1, and supply to load C and load D by feeder 2, just like the case of just like the previous case. And if the ground fault occurs here, then to protect the power lines, the circuit breaker will open, just like in the previous case. So power load A and load B cannot do not have power to use now, but we can use the switch here and switch here to keep supply power to load B. How to do so? We can open this switch and close this switch, and by doing so, the power can supply to load B like this. The power will flow from the feeder 2 to feeder 1 and finally to load B. So load B can have power to use. in this case. And after the ground fault is eliminated, then we can close the switch here and open the switch here and close the circuit breaker. Then it will transfer to the normal case. And finally, the final part of power system is the consumption. And I will introduce the consumption by from the perspective of power system. This is the low curve of the power system in Taiwan and in July 3rd, 2019. And the load is like this. And we can see the load is the minimum load occurs in the early morning. And at about 8 o'clock, the load ramps up rapidly. And before 12 o'clock and after 1 p.m., the peak load occurs due to the hot weather, because people will turn on the air conditioner at noon, so the load is very high. And the load will decrease in 12 p.m. to 1 p.m. because there is a lunch break. So the load will decrease. And after 1 p.m., the load will keep decrease gradually. So this is the load of the whole system. And what factors will affect the load? In the short term, it will be affected by the lifestyle and the weather. Just like this example, when people sleep, then the load will decrease. And when people go to work, then the load will increase very rapidly. And if the hot weather is hot, then people will open the air conditioner, and the load will be high. So in short term, the temperature and the lifestyle of people are very important. And in the long term, the load will be affected by the living standard or the economy and the industrial structure and the climate. So far, I have introduced what power system is, and now I will talk about the operation of the power system, and I will focus on the power dispatch. What is the mission of power dispatch? Safety first. The operator should ensure the system could operate safely and stably. And this includes the safety of the system and the safety of the equipment, and also the stability and reliability of the system. And the system should provide high power quality. Should provide power with high power quality. It means the frequency and voltage should be in a specified range, and which means the supply and the demand should be balanced at all times. And the second mission is economic dispatch. The operator should ensure the safety of the system by the most economic and efficient way, which means he or she should consider the generation cost and the scheduling of the generator and the line loss. For example, the generation cost of fossil fuel and for a nuclear power plant or hydro power plant or PV are all not the same. So the operator should decide the system should be the power should be provided by fossil fuel power plant or nuclear power plant or other power source. And the generator should maintain or inspect or repair regularly, so the operator should also consider the scheduling of the generators. And for line loss, if the generator A is the generation cost of generator A is lower, but it is far from the load, then the line loss will be larger. So maybe the operator will choose another generator B. The generation power may be the generation cost of generator B may be higher, but if the distance between generator B and the load is shorter, then the line loss can be smaller. So finally, the operator may choose generator B rather than generator A. And this is the power flow of the system, and the operator will monitor the power flow and current on each power transmission line and the voltage and angle at each bus. These lines are transmission lines, and these nodes are the bus of the substation or the power system. And the green and red and blue lines are the 345 kilovolts transmission lines in Taiwan. And here is the network of the transmission lines. So the power flow and the current on each transmission line should not too large in order to maintain the stability of the system and to avoid the transmission line to be overheat. And the bus and angle should also be in a reasonable range. But how does the operator know the system is safe? It will simulate. It will assess the safety of the power system, considering N-1 or N-2 situation. What is N-1 and N-2 situation? N-1 is the situation that one accident occurs. The accident may come from the generator or the transmission line or the transformer and so on. And N-2 situation is the situations that two accident occurs. So the operator will simulate the operation of the power system under the case of N-1 and N-2 situation. And if the power system can be stable under N-1 and N-2 situation, then we can say the power system is safe. And assume the state of the power system is safe, then the state is it is in security normal state. And if a disturbance occurs, then it may transfer from stage 1 to stage 2, which means from security normal state to insecurity normal state. And in this case, the operator can do some preventive controls to transmit the state back to secure normal state. And it has to be mentioned that secure normal state and insecure normal state are all normal states. So the operator can operate the system under one of these two states. So it will depend on the judgment of the operator, how it will operate the system. And it will it will make the decision based on the simulation of the operation of the power system under N-1 and N-2 situation. And finally, it will decide the optimal power flow of the system. The optimal flow system might not be the cheapest solution, but it may be a safer one, or it may be not the safest, but it is the cheaper one, because there is usually a trade-off between the economy and the safety. So, if the system is in security normal state, and unfortunately a disturbance or an accident occurs, then the system may transmit to emergency state, and in this state, the system is very dangerous. The power interruption may occur at any times. So the operator should do some emergency control do some corrective control to transmit the state back to the insecure normal state or secure normal state. If the operator did not do so, then the system will break down sooner or later. So the power outage will occur. Then at this time, the system is transmitted to restorative state. And at this time, the operator, it may take a long time for the operator to recover the system back to normal security, normal state. And finally, how to evaluate the performance of a power system? We can evaluate the performance by three aspects. First is the power quality. The quality of the power supplied by the system should meet the specified standards, which means the waveform of the voltage should be a pure sine wave, and the magnitude and frequency of the voltage should be in specified range. And the second one is the system stability. The system should not break down easily due to a small disturbance. And if the distance a system can bear is larger, then the stability of the system is higher. And because the system will face some large disturbance or small disturbance at all times, so system stability is very important. And finally is the system reliability. The power company should provide service to the customer at all times without power interruption in the contract validity period. This is an ideal case, and in fact, the power interruption may occur due to the system construction or maintenance, or some accidents or big disturbance. And we usually take the average power outage time as an indicator. For example, in Taiwan, the average power outage time is 16 minutes per household per year.